Hello everyone, my name is Elijah Proctor, and today we're going to be talking about how data can be misleading or misinterpreted and solutions we can come up for those issues in Python. And so we're going to be using examples from an article called One Algorithm May Not Fit All and How Selection Bias Affects Machine Learning Performance. And so this article basically talks about how machine learning algorithms can accurately diagnose diseases from like radiology images, and sometimes it even performs better than radiologists. The issue happens when trying to use new hospitals or different images. These algorithms actually perform worse. And the reason why they perform worse is because of selection bias. And so selection bias happens when the sample chosen for a study doesn't accurately represent the larger population. And so, one way that we can prevent this from occurring is to use different data sets from different hospitals in this case. And so we have a data set above. We have basically 10 different samples. We have the age of the patient, their gender, an image score, which is like used in radiology, and then which hospital that patient came from, and then diagnosis, whether or not it was positive or negative. And so we're basically making sure that we're grabbing data from three different hospitals. Um, the first hospital is going to be used to train the data, and then hospital B and C are going to be concatenated so that we can use for test data. And so below we just have the results printed out, just to showcase that we're grabbing data from different sources. And so in simple terms, this solution means you're getting a broader view rather than relying on a single, possibly skewed view if you were to only use one hospital. Okay, so another issue that can happen is called overfitting. And so this happens when a model learns not only the underlying patterns in the training data, but also the noise and specific details. And so this can basically lead to like the machine model basically memorizing the data because there's not that much data to pull from. And so in order to prevent this from happening, one solution is to use data augmentation. This is basically where we artificially increase the size and diversity of the training data set. And so it basically creates a modified version of the original data. And so here we have the original data, which is the same data set as above. And here we're going to augment the data by first copying it. We're going to then basically add new ages ranging. We're going to either increase or decrease the data by 6. And then we're going to also do the same for the imaging score, increasing or decreasing by 2 or 3. And so at the end, we're going to concatenate the data together so that it is augmented. And so in simple terms, what we're doing is it's like training the model with many slightly different versions of the same data. And so this makes it more robust and basically makes the data more generalized for the machine learning models. Thank you. That is all.